All right, so in this video, we're going to show how to create this earth mound or berm using just a simple uh, curve and a planar surface. This earth mound can be extruded in this upward or positive direction, or it could also act more like a trench or go in the negative direction. It's completely responsive, so if I move my curve, it'll move with it. If I turn the points on and start shifting things around, it'll all kind of respond. So it's again nice where in terms of Rhino, you have very simple controls with the points and being able to move it, and having Grasshopper kind of recreate everything. And so it's a pretty simple script where you're basically using this surface and series of points and their relationship with that curve, using this graph mapper to basically dictate what that profile of the earth mound looks like. So if I look at it like this, or we can see that profile more or less, we can start to use this to dictate how it looks, right? So if we want it to look really kind of sharp and pointed, we can do it like that. If we want it to be a little bit more squared, we can do it like that. We can adjust the height as well with it. So we have quite a bit of control. For this one, you're going to see that the height of this earth mound is going to be uniform for the entire curve and have the same slope on both sides of the curve. So it's a pretty simple earth mound. We're going to continue to build off of the script to add more versatility to it. So you'll see that in some of the next two videos that we can start to actually control a single high point or even multiple high points. This will, again, kind of just be building off of this original script. And so, again, I like to kind of show you what the end result is going to look like and then walk you through actually making it. So we're going to go ahead and start a new document. I'm going to type show, so you can see, again, we're just dealing with this planar surface. It's just 90 feet by 75 feet. And then I've just used the control point curve to make something. Obviously, you can use whatever type of curve. Like if you want it to be more of a angular or geometric earth mound, you can have it looking like that. It doesn't exactly retain those hard edges. There's other ways to do that, but for the purposes of this, um, it doesn't really um, function that way. So let's go ahead and take this and reference it into Grasshopper. And so the way it's going to work is that we're basically going to take this surface and deconstruct it into a grid of points. So sometimes you might just want to immediately just jump into the surface divide tool, use a number slider for both the U and the V. And this basically is just going to create that number of points or segments in either direction. That's one way to do it. Another way that I kind of like to kind of have a little more control over it is to actually use the dimensions of my surface and generate a grid of points with a defined or designated distance between the points. So in order to do that, I'm going to go to Analysis, Dimensions. So I'm going to take that surface and I'll look at those dimensions. So again, 90 by 75. We'll go ahead and get rid of this slider. Let me go to Math, Divide. I'm going to divide both the U dimension and the V dimension, or the U or the X and the Y, by somewhere between 0.1 feet and let's say 8 feet. So 0.1 is going to be a pretty dense grid of points, but what's nice is that it is going to do it in all directions. All right, so we can see that, yeah, like that's pretty dense. Probably don't need it that crazy for this. I'm going to stick with something around 2. Okay, so that should give us a good layout of points. And so you'll see that all these points are 2 feet from each other. The next thing I'm going to do is now reference my curve. And I'm going to do something very similar where I'm going to take my curve and convert that to a series of points as well. So I'm going to go to curve, divide the curve, and now I can choose a density of points for that curve. And you'll see that it really doesn't matter until you start to get into some of these lower values that'll make a difference. But once you get to a certain density, it isn't going to have a huge effect. So I'll just stick with something around 40 for now. So I've got these. There's another feature I'll show in a little bit where you can use just the curve itself. You don't have to add this step, but there are some limitations that you'll see in a bit. But anyways, I'm gonna now basically measure the distance between my grid of points and the points on this curve. So I'm gonna go to point, closest point, drag that into there, drag this into there. I'm gonna go ahead and flatten this so they're all just kind of grouped together, because when you divide it, it does branch it in, I believe, the U direction. So now I have the distances for all that. And in order to get the graph mapper to work, I want to actually remap these values between 0 and 1. That just gives me a little more control, or requires a little less manual editing. So I'm going to go to Math, Remap. I'm going to find the minimum and maximum, or basically the bounds of numbers. So you'll see that. And it just defaults to 0 and 1, which is exactly what the default is for the graph mapper, which is nice. So go back to parameters, input, graph mapper. I'm going to use these new values for my graph. Now I'm going to go to my graph type and use the Bezier. So basically the way it's going to work is that, let me just turn this on real quick. Basically the distance between my grid of points and the points on my curve get measured with their distance. And that basically gets remapped to be, if this is like 30 feet away over here, it gets remapped to be probably closer to 1. And that's just to help with this graph mapper. So that's what the remapping is doing. I know I've covered in several other videos, but again, just want to reiterate for any new viewers. But the way I want it to work is that basically, here's the x axes, right? So distance between the grid of points and this curve with points. And then the y is going to serve as how much, or how far will these points move in the z axis. So what I wanted to actually do is have the closer it is, so here on the x-axis, to move up the most, which is again 0 and 1 for the y-axis. So I actually want to just have this one go up there and this one down here, so that way as they get really far from my center line, they don't move as much. So I just want this kind of S-curve for now. So I can now use these new graphed values to create that earthwork. So now I'm going to use the move component, drag that into here. I'm going to again move these in the Z direction. And if I just default it for now, it's going to be very subtle because it's only measuring it to go up 1 feet at the most closest, right? So you can see that they have moved up, but it's not really that significant. So what I also want to do is add a multiplier. I'm going to go to multiplication, take these values, do something like 1 less than 30. So now you'll see if I start to drag this, now I start to get more height change. So you'll see that this isn't exactly what that um, initial script looked like. You can see that it's moving all those points, and that's because this graph mapper is basically saying, regardless of how far away it is, it's going to be impacted by my center line. In order to cap it, to kind of confine it within a certain distance of that center line, I need to double click in here and adjust my x-axis. So instead of it going from 0 to 1, if I go to something between 0 and 0.2, so like a fifth of the distance out, now those points, as soon as they reach that, whatever that new remapped value is of 0.2, this, you can kind of see where that threshold is. All of these have a distance beyond 0.2. All these have a distance between 0 and 0.2. So you can obviously adjust if you want it to be even more narrow. You can do something like 0.05. All right, so now it's going to be really kind of thin. If you want it to be slightly wider, so about a third. So that's how you start to dictate that. So I'm going to stick with that 0.2 for now. Perfect. I'm going to turn these off now so I can just have the one grid of points. And now from these grid of points, I'm going to construct a surface from it, right? So again, we've taken that planar surface, we've deconstructed it into a grid of points, we've manipulated those points, and now we want to make a surface from those points. So I'll go back to surface, do surface from points, drag that into there, and then you'll see it also needs the U input. So you might just think like, okay, I've got this number that's going into my U to divide it. I should be able to just drag this right into here and it would do it, but nope, it's gonna automatically, almost guarantee it's gonna always turn red. And there's a reason for that. If you actually look at what it's asking for in that U count, it says number of points in the U direction. When I look at dividing it, it's actually not asking the number of points, but the number of segments in the U direction. There is a difference between that, obviously. So if I think about it, it's a segment is considered the distance between these 2 points, right? So if I just count out 1, 2, 3, 4 points, that's actually 3 segments, right? So there's always one additional point for the total number of segments, right? So if this has 45 segments, this U input actually needs 45 plus 1 to get the 46 points. So in order to correct that, I'm just going to I'm going to right click, go to expression, do x plus 1. Now you'll see I've actually got my surface. I'll turn off those new points. I'll even turn off the original surface. And now you can see that we've got that uniform surface. Forgot to do it here. I'll go ahead and actually add a negative value as well. So that way, if you wanted to, instead of being a mound to be some kind of trench, you can just drag that into the negative value and now it's being dug out. So yeah, that's how you can start to create this uniform surface. There are going to be some weird things where it looks like it's not really working correctly right there, right? That's really a product of just, again, the Grasshopper display settings. If you go to this icon and choose high quality, you'll see that now it's nice and smooth. And you can definitely tell that more when you have like something that's looking a little more kind of spaced out like that. You'll see if, again, it looks a little bit different. And this is what I was saying, where as the spacing for that center line for the points, as that starts to decrease, it actually starts to create a completely different outcome, which is not to say is a bad thing. Maybe that's what you're going for, but if you want it to be nice and uniform, you do need it fairly dense. But then once you get to a certain density, you aren't going to really see much difference, right? Once I'm around like the 50 and up, there's really very little difference that you'll see. So you don't have to have it too crazy. But that does bring me to another point that you can see that if you just place a series of random points, you can actually have these operating in a very similar way as a curve. So I'm gonna reference just these random points. And now, basically, each one of those points is gonna do that same thing of creating that profile, right? So if I want them to look a little bit different, I can have it look more like that. Can really kind of sharpen it. You can see this one's a little bit different, probably because it's just really close to one of those grid points. If you want them to read less pointed, right? If you want them to almost be like a kind of plateau or this trimmed surface, you can have it looking like that. So this would obviously operate with just having random points. It doesn't necessarily have to be a curve. But let me go back to this. Another operation or component you could use is the uh, curve closest point. It's going to work very similarly where you have your grid of points and a curve. However, so it does give you a little more accurate distance. So if I just plug this into this distance into those new things, you'll see that it doesn't really change much. It's just a little bit more accurate, I guess. And it's just one less step, right? Now you don't have to worry about dividing it by points. So that's kind of the benefits, just a little less operation for it. However, it doesn't really work for multiple point or multiple curves. If I want to add another curve here, so let's try multiple curves. You'll see that it actually kind of, let's see, it doesn't even recognize it, right? So you don't want to use it for that. However, with this operation, if I go ahead and flatten this and drag the distance down to there, now you'll see that it actually recognizes both of those curves. So you can add several other curves in order to create it. And as they get closer, it'll actually start to kind of merge the landforms together as well, which is kind of cool. So you can have it looking like that. You can basically, with that rhino curve still on, you can just kind of split from it. And then again, setting multiple curves in order to kind of get this nice blending earthwork. So again, it doesn't matter like that this has a slightly more dense grid of points. It's still, they're all gonna look the same. So it's a good way to kind of understand how you can, again, use multiple curves to create something a little more intricate. Again, there is the limitations that the earth mounds are perfectly or at the same exact height. As we continue to build off of the script, you'll see that we can start to basically taper it towards the ends, have one designated kind of high point, or then continue to develop even further and have multiple high points and have them all build off of there. So again, we are going to continue to build off of that. So check out the next two videos to see how that stuff's done. And again, you can have them as these tall berms or these cutouts in the landscape. They'll both work the same way. So.